All right, welcome everybody to class today. Uh, Before we get started, I just want to make an announcement that depending on when you're watching this video, you're going to receive, or maybe you might have already received, testing instructions for the exam that we have next week. So just know that these dates that I'm telling you, this only applies if you're in my summer 2022 class. If you're watching this video sometime in a later time, these dates don't apply. But for those of you that are in the summer class this summer, summer 2022, we do have a test next week, Wednesday. And so what next week is going to look like is Monday, we still have one more lecture on new material. We're going to be finishing up section 5.2 and doing 2.6. And then next week, Tuesday, is a test review. So for the test review, I'm going to go over the sample exams that are on my website. So if you go to my website and hit the button for your class, you'll be able to see test review. Click on that, and it's going to give you a PDF of a blank PDF you can get of the exam, and that's what we're going to be going through on next week, Tuesday. The actual test problems look very similar to the ones that are on the sample exam, and so that's why we'll do those for review. In the testing instructions, I'll give you instructions on how you want to be able to scan your test work. So with the email that I'm going to be sending out, you should get an attachment with it, and the attachment is going to be all the instructions for each question on the exam, but there just won't be any numbers written on there. The actual numbers you'll get on your test, because everybody gets their own test version. All the numbers are different, but you will be getting some scratch work, a place where you can write all your work down on there. Now, if you don't have a printer at home, don't worry about it, because then you can just use your own scratch paper. But one way or another, you'll have to be able to scan work back to me. So you can either use a scanner at home, or if you don't have that, then I will in the email, I'm going to put instructions on how to scan your work by using one of the scanning apps. There's several of them out there. Adobe Scan is one that I like a lot. There's also Cam Scanner and other ones that are out there as well. But I'm going to put my recommendation, and I'll also put a link to a YouTube video that shows you how to use that particular scanning app. And so that way you'll be able to scan your work back to me. So once you get you'll have an hour and a half for the exam. And once the exam is finished, you'll have 30 minutes to scan your work back to me. And so I must receive it within a half hour of the test, of your test ending. And so I do need to receive that in order for you to receive full credit. So even if you get the right answer in my open math, if I don't see work supporting your answer, you're not going to get full credit for that question. But on the flip side, if you get the question wrong, I might be able to give you extra bonus points, partial credit points, if your work is correct. If the work that you have so far is in the right direction, then I'll give you some points for trying that problem. So that's going to happen next week. Now, there won't be any lecture next week, Wednesday, because that's the day that we have the test. Now, you don't have to take the test during this testing period. It's actually open a full 24-hour period. So you can take it any time in that 24-hour period. Just know that the test is automatically going to submit at the end of the day at 11:59 p.m. on Wednesday. So if you're starting it later like that, you don't want to start it any later than 10 o'clock. Otherwise, you're not going to get or actually 10:30. If you start any later than 10:30, then you're not going to have the full time for the exam. So you want to make sure that you have the full time allowed for that. And then what's going to happen is it'll take me several days, but you'll get an email from me. Each person in the class will get an individual email, and I'll tell you what your new score is going to be, and then I'll give you instructions on how you can view the feedback I gave you in there, because I'll write feedback for all the questions on there, and then how you can answer that, like the answer key and things like that. So I'll provide all that after once the test is done. You may not hear from me for a few days, but eventually I will get to you and write back with your new adjusted score and things like that. So that's just an overview I wanted to give you. So you want to make sure, like over the weekend, maybe you should go ahead and, if you don't have a scanner at home, then I would definitely try downloading a scanning app to your phone and playing around with it, and make sure you know how it works. So try scanning a couple sample pages and things like that, and make sure you're able to attach them to an email, because you will have to email those back to me in Canvas. So Canvas is how you're going to send the work back to me. So just send an email to me in Canvas with that. So the only difference between the problems that you do in homework and the problems that you see on the actual test is, with the homework, there's no submit button, but for the exam, in the upper right-hand corner, you will see a timer on there, and submit button will be there. And so that one you will have to hit submit on in order to get that to go through. But again, that's going to be next week. Next week, Wednesday, is when we're going to be having that. So with all that, let's go ahead and start the lesson for today. Section 5.1 is where we left off. We did finish all of the 2.5 yesterday. We're skipping 2.6. We're going to come back to it after we do these, because these two sections kind of follow along with the function notation we were talking about, and then we'll jump back to 2.6. We'll do that next week. So we're going to do 5.1 and 5.2 because they have to do with functions. So here is the lessons will be on evaluate composite functions. And by the way, this is the last section of new material that you that you need to complete for the homework this week. We are going to start 5.2, but that's not going to be due until the following Sunday. So 5.1 is the only one that's going to be due this coming Sunday. All right, so along with the other sessions we did this week as well, of course. Okay, so composite functions are a way that you put one function into the other. And so if you look at what it says here, we have, this is pronounced f of g of x. So f of g of x, this is not multiplication. We're not multiplying f times g. If we had that, it'd be f of x with a dot and then g of x. That's not the notation that we have here. You're actually putting the g function inside of the f function is what you're doing there on this kind of problem. With the other one, we have g of f of x. Again, you're putting the f of x inside of the g. It's not multiplication for that. So you're putting one function into the other is what you're doing there in this case. So let's move on to let's do the first example now that we have these definitions. So let's do this. I'll leave the definitions up here so we can refer back to them. So it says given, okay, so we have our two functions. They have to give you these. F of x and g of x are given here. We want to find all of this. Okay, so first thing we want to find is f of g of 2. And what it says right here is we're first rewriting it with the definition. We're replacing the x with g of 2. So instead of the, so we're using this right here because we have f of g. It's just that instead of the x, we're putting a 2 in there because it actually gave us a number this time instead of an x. So we want to do f of g of 2. Well, how we're going to do that is we first want to figure out what g of 2 is. Once we have that, we can put that back into here and then solve and get the answer. G of 2 means that we put a 2 in for x right here and plus 1. So g of 2 is equal to 7. Okay, so now that I have this complete, we're now going to put our original problem had f of g of 2. That's going to now turn into f of 7 instead. So we took out the g of 2, replace it with a 7. That says that we have to go back up to the f function and put a 7 in there for the x. So now I have 5 times 7 minus 4. So f of 7 is equal to 31. Okay, so so this means that f of g of 2 is equal to 31. So I start with the inside always. I compute the inside, replace the g of 2 with the 7. That's what I got when I did that. So all this goes away and I have a 7 in there instead. And then I just compute that. And then that's my answer for the whole thing. F of g of 2 is 31. Next, I want to find g of f of negative 1. And you can see it, we've rewritten it just like this. So the first thing we want to always work on is the inside. We want to find f of -1. Well, the f function up here was 5x minus 4. So it means we want to do a 5 times -1 minus 4. So f of -1 equals -9. So we found the first thing. So then we're going to come over and replace the f of -1 with a -9, which means now we have g of -9. Okay, so g of -9, we just go up to the g function. That's going to be 3 times -9 plus 1. And so this is going to give us -27 plus 1, so we get -26. So that tells us that g of f of -1 is equal to -26. That's going to be our answer for that one. Now, the next couple problems that we're going to do, we're still using the same two functions, but this time they don't have a number in there for us. So the only way we can get a numerical answer is if there's a number inside the parentheses here. If they don't give you that, that means you can only get an answer with x in it. And that's the ones we're going to look at next. We want to do f of g of x, which really means this, f with a g of x inside. So again, we're using the definition for these. Okay, so f of g, so I have 5x minus 4 and 3x plus 1. So what I need to do first, as always, I'm going to work with the inside first. So I already know what the g of x is. So g of x, I'm going to replace the g of x with 3x plus 1. So I have 3x plus 1 that I'm doing. So I just got rid of the g of x, got rid of it, replaced it with a 3x plus 1. So now I want to find f of 3x plus 1. Recall that f of x is equal to 5x minus 4, so we don't have to flip up to the top again. Okay, so this is our original f that we have. What I'm going to do is remove the x from here, replace it with 3x plus 1. So I have 5 times blank. So I remove the x from the original f function there. We're going to replace it with 3x plus 1. Now we're just going to simplify all this. We're going to get 15x plus 5 minus 4. And then we get 15x plus 1. Okay, so that means that f of g of x is equal to 15x plus 1. Okay, so this is, we can't go any further with this because since we don't have a number provided for the x, then we just have to leave it in terms of x. Now, one thing I want to show you about this is originally back up in this part, we were asked to find f of g of 2. And when we did that, we got 31. I have found f of g of x, which means if I put a 2 in here for x, I get 15 times 2 is 30 plus 1, 31. I get exactly the same answer as I got up above here. So there's actually 2 different ways that you could do these kind of problems with a number. You could do it all numerically like we did initially, or you can find f of g of x, and then once you get done with that, then just plug a 2 into your answer to get that. We're also going to show that you can do the same thing with g of f of -1. We can find g of f of x first, and then plug a -1 in. In fact, that's the next problem that we're going to do down here. We want to find this. Now, before we do that one, let's go ahead and write out the f and the g. So f of x is 5x minus 4, and g of x is equal to 3x plus 1. Okay, so these are the 2 original functions. We can keep them at the top of the page so we can refer back to those. So let's do now the next one. We're going to g of f of x, which again, if you use the definition, it's saying that you're going to put the the f into the g. So it's actually the reverse of what we just did before. So instead of the f of x, I'm going to replace the f of x with 5x minus 4. So this is now what I need to figure out. I need to do g of 5x minus 4. Okay, so what that means is I'm going to go with the g function, remove the x from there, replace it with 5x minus 4. Okay, that's going to be it. So here is the g of x function. I took out the x. So it's 3 times a blank and then plus 1. The blank gets filled in with 5x minus 4. So now I'm just going to multiply that out and simplify. And I get 15x minus 11 as a result there. All right, so 15x minus 11 is what I got. Now, originally in part B asks you to find g of f of negative 1. Notice if you put negative 1 in here, you get negative 15 minus 11, and you get negative 26, which is exactly the same answer we got by doing it numerically. So again, as you can see here, you can do it algebraically first with just the x, then plug the number in your answer afterwards. And so that's 2 different ways that you could accomplish this. Okay, now these next 2 over here, this is using f of x. And so you're putting the f inside of itself is what you're doing here. So for this one, the f of x is 5x minus 4. And you're putting 5x minus 4 into itself. So the way that you're going to do that is, here's the original f function. We're going to remove the x from that, just like this. And then instead of the x, we're going to put 5x minus 4 in there instead. So again, you're putting the f inside of itself. So that's going to give you 25x minus 20 minus 4. And then that's going to end up giving you 25x minus 24. And then that would be your answer. F of x is equal to 25x minus 24. And that's going to be your answer there. So we didn't use the g function at all there. We just used the f function only, because that's all that we have here. We have f of f means you're putting f into itself, is what you're doing there. Now we're going to do a similar one with the g. So I'm going to write right here that the g of x, just to remind us, was 3x plus 1. Okay, so now we're just working with the g function only. So this is g of x. We're going to replace this g of x inside here with 3x plus 1. And that means that you're going to put 3x plus 1 into itself. So here is the g function without the x there. And then the x gets replaced with 3x plus 1. So then you get 9x plus 3 plus 1, or 9x plus 4. So g of x is going to be equal to 9x plus 4. Okay, and that would be your final answer on that one. Again, these you can't simplify or do any more with because we don't know what the x value is. So that's why we just leave our answer there in terms of x. All right, so now we'll go on to the next one. Okay, so we're kind of doing the same thing again, except I'm gonna do a couple of these kind of problems where we do multiple parts, but then I'm looking at some different functions for you, because that's kind of reflected in the homework as far as what kind of things it's asking you to find. Some problems are all numerical problems only, and then other problems have you do these all in terms of x. And so that's the type of problems that we're going to be taking a look at here. All right. And then I'm also going to look at, I'll be doing a couple of these homework problem or two. We'll take a look at the end here to tie things all together with that. So let's take a look at these here. And we have all these different parts. So let's start with f of g of -1 is the same thing as this right here. Now, when you see these problems on a test, you're not going to see this part written out for you like that. You'll have to know to use the definition to write it specifically this way. They are written this way in your notes, but in actuality, you'll be writing this down on your own as part of the first step that you'll have on these. And you'll see that when we do the review next week for that. Okay, so this, we have f of g of -1. We always start with the inside with these, so we want to find g of -1 first. And we're going to go up to in the g function, and we have 2 times -1 squared minus 1. So g of -1 is going to be equal to, this is positive 2 here, because -1 squared is 1. 2 minus 1 is 1. So we have that. Next thing we want to do is replace the g of -1 with 1. So now we have to find f of 1. The f function is here. It's x plus 3. We'll put a 1 in there for x, 1 plus 3. And you're going to get a 4 for that. So what that tells us is that f of g of -1 is equal to 4. That's the answer that you'll put, your final answer you'll put on this problem for part A. Next, let's do part B, f of 0. We're starting with the inside. We'll always do the inside first. Okay, so f of 0 means we got to put a 0 into the x right here. So f of x equals 0 plus 3, which equals 3. Let's write that. I'll write this down below here. F of 0 equals 3. Now we have to replace the f of 0 with 3. So next we're going to find g of 3, which means we have to go into the g function, replace the x with the 3. So we have 2 times 3 squared minus 1. So g of 3, you're going to get, this is order of operations says we got to do the square first. So we have 2 times 9 minus 1, and g of 3 is equal to 17, and that's what g of f is equal to. So g of f of 0 is equal to 17. Okay, so that's the answer you'll put for part B. Now the next ones that they ask you to do up here that we see here, f of g, g of f, all these that have x in it, that means we're just going to get an expression for our answer, not a numerical answer. So all these other ones are going to have x in our answers there because there's no numbers included. So let's jump to doing that. Okay, so f of g of x is the next one we're going to do. Notice that the definition there says this, it's f with the g of x inside. So first thing we want to do is replace the g of x with the formula, and recall from before that g of x is equal to 2x squared minus 1. So I'm going to put 2x squared minus 1 in here for the f. Okay, so I put that in, that's what it will look like. Now, in order to do this, we have to put 2x squared minus 1 into the f function. The f function is x plus 3. If I remove the x, I'm going to replace it with 2x squared minus 1. And there's a minus 3 here because the minus 3 was part of the f of x function. It was, I'm sorry, plus 3, not minus 3. So all this right here, this 2x squared minus 1, that was what we put in there for x. The plus 3 was the rest of the formula that was there. It was f of x equals x plus 3. So that's where the plus 3 comes from. Now we just have to simplify this. 2x squared minus 1 plus 3 is going to be plus 2. And then that's all we need to do on that one. That's going to be our answer, f of g of x is equal to 2x squared plus 2. You could factor it, but it's not necessary in this case. So that's going to be our answer. Notice that up here, if we want to find f of g of -1, if I put if I put that in here for that, -1 squared is going to give you a 1, and you get 2 plus 2, which is 4. Same answer we got up here for f of g of -1. So again, it checks here by doing the, you can always check your work for the numerical answer by plugging that number into your x here, and you should get the same answer as the one you did before. So it's a way to check to see if your work is right or not. All right, so next we're going to go on to g of f of x. Okay, so we want to do g and then put the f function there. We mentioned before that the f of x is equal to x plus 3. So I put an x plus 3 in there instead of f of x. To do this, we need to put that into the, we're putting this into the g function. So g of x before, I'll just write it out again. Okay. G of x that was given above was 2x squared minus 1. What I want to do is remove the x from there. So if I get rid of this x here, I have a space. It's blank here. The space gets filled in with x plus 3. Okay, so I put that inside. From here, I can simplify it, but actually in my open math, it doesn't really matter if you expand this or not. We could actually just keep this as our answer. And up here, we wanted to do g of 3, or I'm sorry, g of f of 0. Okay, so if I put a 0 in here, then I'm going to get 2 times 3 squared, which is going to be 18 minus 1 is 17, and that's the answer we got above here. So again, we just confirm that our answer here is correct by doing that. So again, you could leave it this way. It's okay. I don't really prefer any particular way to write your answer if a problem like this is on a test. You don't have to expand it unless it says specifically to do so. But there was no instructions on here about us expanding our answer. I did do that in the written notes for you, but here I'm not going to do that. I'll just leave our answer like that. All right, so I want to do f of f and g of g. So let's write the two functions up here again so remember what those are. F of x is x plus 3, and g of x was the 2x squared, and then that was minus 1. Okay, so minus 1 we'll put here. So now we have both of those up there. Okay, so now the first thing we'll do is the f of x, which means that I want to put x plus 3 into itself. Now to do this, I'm just going to replace the x there with a blank. So I have a blank plus 3. The space gets filled in with x plus 3. So I'm putting x plus 3 in place of the x here. If I simplify that, x plus 6 is what we end up getting. So f of x is equal to x plus 6. And that's going to be our answer there. G of x. I'm replacing the g of x inside the parentheses with 2x squared minus 1. What that means is I'm going to replace the x that's here with itself, with 2x squared minus 1. So I have 2 times a blank squared minus 1. So I took out the x in the g function. That's why the square is still there. Replace the x, the blank, with 2x squared minus 1. Now this is another one that you could expand, and if you expand it, you'll get x to the 4th power. But again, if you were to put this into my open math, it would accept that as an answer. So again, I did show that in the notes where I expanded it, but I'm not going to do that here. Just go ahead and leave that as your answer. All right, now this one does have special instructions for us because now we have a fraction. So we have a square and we have a fraction that's here. And we're finding pretty much all the same parts that we had before. Now it says express all single fractions in factored form if possible. So we want to express all these. So if we end up with two fractions, we want to combine them to a single fraction and factor them also, is what these instructions say. So this problem has very specific instructions. So we do have to follow those, but if you don't see these specific instructions in the homework, then you don't have to worry about following something like that. So in this case, we are going to go ahead and follow these. If we do get more than one fraction, we want to combine them together with common denominators. And also, if there's anything that we can factor, we do want to do that as well. So we'll do that now for this. Okay, so starting out with that, we're going to find f of g of 0. So we always start with the inside. So g of 0, we do. Here's the g function, and then we get, so we get division by 0. So we can't do this one. And so this actually is undefined. And this does happen rarely, but it does happen occasionally. Now, if you get undefined for that, that means that you have to say that f of g of 0 is undefined as well. It's undefined because we got a division by 0 happening. And unfortunately, there's nothing more we can do with that problem. We just say f of g of 0 is undefined. Now, the next question it asks us to do is f of g of x. So we're gonna do this, and we should actually get, if we try putting a 0 into the answer we get for part B, we should also get undefined as well. Let's check it out and make sure that's what we get. Instead of g of x, I'm going to replace it with, this is negative 1 over x. So I'm going to put that into here, negative 1 over x. Okay, so took out the g of x, replaced it with the formula negative 1 over x. This means I got to go into the f function, replace the x with negative 1 over x. Now, what I'm going to do before I do that, though, is notice how it says we want to put these in the factored form. What I'm going to do is I'm going to rewrite this and put this into factored form first. That way, anything I plug into this afterwards is already going to be in factored form. All right, so let's do, this is going to be 2 minus x and 2 plus x we get for that. So that's a factored form that we have. So something like this, if I put it into here, I'll get 2 minus. So actually, if I put the negative 1 over x in for the x here, so this is the, instead of using the original one, I'm going to use the factored form here. If I have 2 minus a negative, that's going to turn that into a plus. And then if I have 2 plus a negative, that's going to be 2 minus 1 over x. Okay. Now it's factored, but then it also says we want to write this as a single fraction. Okay, so as a single fraction, what we can do here is we can get some common denominators for each of these and then multiply those together. So let's do a common denominator. So I am doing this a little bit differently than I have in the notes, just to let you know. I did that a different process in the notes, but I just wanted to show you an alternate way of doing the same problem. Let's do, if I have 2 plus 1 over x, like that, I want to add that together. What I would do is make this 2 over 1, and then I want to get some common denominators. The common denominator would be an x here. So if I multiply that out, I get 2x plus 1 over x. Okay, so that's getting common denominators with that one. If I have 2 minus 1 over x, I'm going to do exactly the same process. I have common denominator needs to be x, so I'm going to multiply the 2 by x over x. And that's going to equal 2x. And I'm only multiplying the first fraction by the x. That's why I'm not multiplying the 1 by x. It's just the first fraction only that I'm doing. So you know what? Actually, I think I let me take a step back. I think I'm doing too many steps at once for this. Apologize for that. Let me erase this because I tried to jump ahead too much there for you. Let me go back to the backup and show you what happens when I do this. You get here 2x over x plus 1 over x is what we get as a result. So I should have showed you this step first. 2x over x you get, and then you can combine it together as 2x plus 1 over x. So I just want to make that clear that you see where that's coming from. I'm going to do the same thing down here. I get 2x over x minus 1 over x, and so that's 2x minus 1 over x like that. So that's both of these now have common denominators, which means that I can write both of these as 2x plus 1 over x, 2x minus 1 over x, just like that. And that would be acceptable to leave your answer because it's each of these are single fractions and they are also factored. But of course, you could also, if you wanted to FOIL this and multiply this together, you could do that as well, you know, and make it 2x plus 1, 2x minus 1 over x squared. You could do that as well, but there's a couple different ways that the answer will be accepted here, but probably either one of these is going to be fine. But I'll just go ahead and I'll say that this is our answer, f of g of x equals, let's say, we'll just use this as our answer here, 2x plus 1, 2x minus 1 over x squared. So it's just another way of doing it. You may find this to be either easier or harder than the way I showed in the notes. You should just follow whatever way you think is easiest for that. Either way, though, there's some algebra involved because we have to do some factoring and multiplying, common denominators, those kind of things. Now, originally, we're up here in part A, we were asked to do f of g of 0. Notice that either this answer or this answer, if you plug a 0 in for x, you still get division by 0. So therefore, f of g is still going to be undefined, excuse me, in this part. So both of these are going to be undefined. Okay, so no matter what, if you put a 0 in there. Okay, so we have that. That's complete for B. For part C, we want to do g of f of x. So I'm going to write down the f and the g functions again for us here. F of x is 4 minus x squared. G of x is negative 1 over x. Okay, so that's our two original functions. So now we want to find g of f of x, which means that we have to replace the f of x with 4 minus x squared. So we're going to put this into the g. To do that, we just have negative 1 over, so that's basically writing the fraction without the x in it. The x gets replaced with 4 minus x squared. Now, it already is a single fraction, but we can now, when we write our answer, g of f of x, we're going to just write this as a factored form. Negative 1 over 2 minus x, 2 plus x. Okay, so that was that factored form that you could have put in from the start as well. So instead of using 4 minus x squared, we could just use our factored version that we did earlier and plug that in there and got that as the answer. It's a single fraction that's factored, and so that would be as far as we have to go. Next, we're going to do f of x. So this one didn't have the definition written out, so we have to provide the definition this time. That's what it would look like. You're just taking the f and you're putting f of x inside of itself. What that would look like here is f of x is 4 minus x squared. So I'm putting 4x minus squared in for the f of x. And now I have to put 4 minus x squared into the x here. So the template would look like this. Here's the original f of x. I just took out the x, but the square is still there. This gets replaced with 4 minus x squared. This is not a fraction. So it doesn't have to be fraction or factored form with it. We could leave our answer as that. Now, what you might be wondering is, well, what if I use the factored version? What happens if I use 2 minus x and 2 plus x? What if I were to use this? So I'm going to do this problem again, but I'm going to use this version of the f of x instead of this version of the f of x. So if I do that this time, I'm going to do f of 2 plus x, 2 minus x, just like this. And so basically that would mean I'm putting all this inside of here. So that might be a little bit more confusing if you were to do it that way. I just wanted to show you the setup of what that would look like, but that probably would be a little bit harder to do. So in this case, that's why I'm using the original one, the 4 minus x squared, because that's a little bit easier to see in here, because otherwise you have to put every x that you see here gets replaced with 2 plus x, 2 minus x. It makes it a little bit messy when you do that, and it's not necessary to do that. This answer actually would be accepted in my open math there. So we'll just leave this as the answer. No, you could do it the other way as well, but again, we won't bother showing that because that's going to be more confusing than the first one that we did here. Last one is g of x. So this definition is a g with a -1. I'm sorry, it's jumping ahead here. G of x we have to start with first, and then that gets replaced with -1 over x. Okay, so definition is g of x. Take out the g of x, replace it with -1 over x. The original, the g function there is -1 over an x. The x I'm leaving blank. I'm going to replace that with this here. So that parenthesis there, that did have an x originally, I'm replacing the x with -1 over x. We have to just flip and multiply this now. So we have -1. Really, the top fraction there, you can write that as -1 over 1. We're going to multiply this by the reciprocal of the bottom one. That's x over -1. -1's cancel out, and we get x. We get x as our answer there, and that's going to be our final answer. So you would just write g of x is equal to x. And the one up here, we had f of x is equal to 4 minus x squared. So we just left our answer, above answer, the part F, it was this one here. All right, so now we have that one complete. And so let's move on to this one here. Okay, now there's a couple questions. We're kind of moving on to different types of questions that this homework is going to have for us. So we're going to talk about those next. And then we'll take a look at a couple sample homework problems here if there's enough time. So we've got f of x and g of x is here. It says find the domain of f of g of x in set builder notation. Now, set builder notation, I have to talk about that first. So set builder notation looks like this. So get rid of that box. Your set builder notation always starts with this notation first. There's a set symbol, there's an X, and the bar here is another word for such that. Okay, so that bar means such that. Okay, that's what that means there. So this is saying the set of all X such that, and then you put whatever statement in there. You might have, so you'll put another statement inside here. It might be something like x is greater than 3, x is less than 3, x is not equal to 0, something like that. You'll put a statement you'll put inside here. So that's what we mean by set builder. It's an alternative way of writing an answer, an inequality. Instead of using interval notation, it's using set builder notation. That's what the homework has you do. It has you do the set builder. On a test, I'll have you do something with interval notation instead, but because I'm following what the homework says to do. That's why I'm kind of just displaying it this way to understand what that actually means. So with that, we'll come back and we'll put something in here later for our answer. So first we got to find f of g of x. So f of g of x is this here. So you have to make sure you know what the definition is for that first. This is saying we have to put the g of x inside of the f. Okay, so if I take out the g of x, I'm going to replace it with 1 over x. And now that's saying I got to put 1 over x into the x in the f function. So if I do that, that's going to be 5 over, so I'll leave a blank here. So I'll have a blank, and then I have -3 with that. Apologize for my dog barking again at nothing as usual. Okay, so this, the blank that's here that wasn't x, we're going to replace it with 1 over x. So now I have this. But we don't want to leave our answer like this because we have a complex fraction. So we'd like to get this to be one fraction only on the bottom. So I want to come one fraction total for the whole thing. So I'm going to do a little bit more work to this. So let's go ahead and get common denominators with the bottom. And so I'm going to I have 1 over x, and then the 3 over here, that can be written as 3 over 1. And then I can write this as x over x as a result there, which now allows us to get common denominators with that now, because now I have the x is the common denominator down below there. Now I'm going to take this and I'm going to turn this from division into multiplication. You take the top fraction and multiply it by the reciprocal of the bottom fraction. The top fraction really is a fraction. It's 5 over 1. And 5 over 1, we're going to multiply by x over 1 minus 3x. Okay, so I flipped and multiplied that one. So then if I multiply that out, what I get is I get f of g of x is equal to 5x over 1 minus 3x. That's what I get. So that's the first thing it's going to ask you to do is find f of g of x first, and then it's going to ask you to find the domain of that one. Now for the domain, because we have something on the bottom that is because we have a fraction, it's possible the bottom could equal 0. So I know that 1 minus 3x is not equal to 0 based on this. And if I solve that, I get 1 is not equal to 3x, and I get that x is not equal to 1/3 when I solve that. If I put 1/3 into here, the 3's cancel out, I get 1 minus 1, so I get division by 0. So I know for sure that in here, I'm going to put x is not equal. So this is how the set builder notation works. You have the set of all x such that x is not equal to 1/3, and with your set symbol. Now, unfortunately, if I were to enter this into my open math, unfortunately, it would mark me wrong. Okay, now the reason why it's wrong is because we're actually missing another number here that is not included. So that's why I want to go over this kind of problem, because it's a little bit tricky here. What you also have to consider is you have to consider this, the very first step. If I was to leave my answer like this, I would see if there's another number that would cause division by 0. In fact, 0 there, because I have 1 over x here. If I plug a 0 into this first step, that would cause division by 0. So when you do these problems, you have to look at domain twice when you go through these kind of problems. The first time you look at domain is your very first step. When you plug the fraction in, you're going to find the domain in that first step. So that tells me that x is not equal to 0. Then you're going to go through all this common denominator steps to get the final answer of f of g of x. And then you do domain one more time. So you have to find domain at 2 different spots. And it's specifically if you have these types of problems where the f and the g are both fractions and they're asking to find a domain, then that's when you'll have to do that. So in this case, I also have here, let me erase this so I have enough space to write it. What you're also going to have is x is not equal to 0 as well. So this is your correct answer that you'll have on this. Now, you don't have to put the set symbol, the x in the set bar. On the ones in the homework, you're just going to type in just these two statements. X is not equal to 1/3 and x is not equal to 0. And that's what you're going to type in for that. Okay, so that's what you'll put in for that particular one. Okay, so they have these you gotta be careful on because again, there are ones that you have to be very specific on how you write that. Now, this one says set builder notation. I'm also going to show you that in interval notation too. X is not equal to 0. It says in the chat because of this x right here. If you put a 0 in this stage, at that point, you're going to get division by 0. That's why x cannot equal 0. You got to look at the first fraction that you do. If you put a 0 in there for x, you get division by 0 in that first step. So that's why 0 is also not included there. Okay, so this is set builder, but let's do interval notation as well. So interval, because I think there's some questions ask you for set builder and some ask for interval notation as well. Now, interval notation is basically going to include all the numbers except for 0 and 1/3. So it's going to include all the numbers before 0. It's going to include the numbers between 0 and 1/3. And it's going to include all the numbers greater than 1/3. So 1/3 to infinity. So that's what it would look like in interval notation. It's everything except for 0 and 1/3. That's why I've got parentheses on all these, because the 0 and 1/3 is not included. So it could ask you for either set builder notation or it could ask you for interval notation on that. And so when I get done with these notes here, I'm going to come back and I'm going to show you the problem in my open math, and I'll do another one of these fraction ones again, just to make sure we're kind of clear on that. So I'm going to go through another one of these completely for you in my open math a little bit later. Okay, so let's go ahead and we'll continue with this, and then we'll come back to it. So I'm going to do these. These are I got a couple more problems to do here left. So let's do this one next. Find functions f and g so that f of g of x equals h of x, and they give you the h of x. So what this problem is asking you to do is they actually want you to find the f of x and g of x functions that would form and give you this one here. H of x is 1 plus x squared squared. So that's what it's asking you to do. So this is actually the opposite of what we were just doing. Ones we were doing before, they give you the f and the g, and you want to find the composed function. So now they're going to give you the one that's already composed together, and they want you to break it apart into the two original pieces there. What you're going to do on this, the way that you find this is whatever function that you see that's inside some parentheses, that's automatically going to become your g of x, because your g of x is always the inside function. So in this case, I'm just going to write 1 plus x squared because I already see that that's what's inside the parentheses, just like that. So that automatically is going to be our first answer for g of x. Just replace just look at whatever's inside the parentheses, 1 plus x squared. Now, normally when we were doing these before, typically what would happen is we replace an x with a g of x. Well, if we're going to be going on the opposite steps, in order to find the f function, what you're going to do is you're going to take this one and you're going to remove the g and replace it with an x. So I have h of x equals, so if I take out what I'm going to do here is I'm going to remove the g of x that we've already identified, the piece that was inside. So if I take that out, then I'm just going to replace it with an x. And that's how I'm going to get my f of x function there. And then that would be it. That would be the entire answer on that. Again, Whatever is inside automatically becomes g of x. Then remove the g of x, replace that with an x. That's going to give you the other function. So we want to do another example of that. Now this h of x function that we have down here, this next one, we want to do a little bit of work to that first. So what I want to do is, this will make it easier to recognize what the g of x is I'm going to do a factoring step here. And so I'm going to factor out a -2 from the second piece. So if I factor out a -2 from there, that's going to make that positive, and then +2 divided by -2 is you have -1. So that's what you end up with left over. So I want to find out what the f of x function and the g of x functions are for this problem. Now notice that I have something that repeats here. I've got 2x minus 1 inside the square root here, and I have 2x minus 1 inside the parentheses there. It's not a coincidence that these are both the same. That's how the problem was set up. So what I'm going to put here is my g of x is the thing that repeats, or again, it's the thing that's inside of something else. So I have 2x minus 1 right there. So it's repeating. What I want to do to find the f of x function is what I need to do next here is remove the 2x minus 1. So I remove it, I get these blanks here, and I'm just going to replace them both with x's. So I got rid of the g of x, replace them both with x. I'm left with square root of x minus 2x. So square root of x minus 2x, and that's what I have for my answer there. You can always check to see if this works by finding out f of g of x. So if I find f of g of x, that means the g goes into the f. I would put in 2x minus 1 in for both the x's, and that would in fact give me the same thing that I started with. So again, you're just kind of doing these in reverse of what we've done before. Now, another type of question that they're going to give you in the homework is one where they give you some kind of a table and you're reading your values off of a table. That's actually the first question you'll see in the homework. So I do want to do one of those for you. One of these that's like the homework. And so that way we can, we'll know how to do that. Okay, so this is the last problem that we're going to do. So I wanted to end with one that's like the homework, and we'll do another one of those domain problems as well to finish this off. Okay, so first one here, we'll find f of g of 1. Remember that. So these are all numerical problems. This whole problem is all numerical. F of g of 1 means we want to rewrite it by using the definition. So it's always f, and then it goes in the order of the way you see that there. So f and g, like that. We want to begin by finding out what g of 1 is. And normally, if we had an equation, we could just plug 1 into the formula and get the answer. Instead, it's giving you this table. So we want to read the value off the table. G of 1, the 1 is the x value. So we're going to go over to the 1 column, and we just go down to the g, the row. So right here, 0. So go over to the 1 column, and we get this value right here. That's where x is 1 and then g is 0. So that's where we're getting that from. Okay, so we have that one's there. And so I have now a 0 is going to go inside of it. Now we want to put the 0 into the f. Okay, so we go to the 0 column and we go down to the f row right there, and we get 5. So f of 0 equals 5. That means now I know that f of g of 1 is equal to 5. Okay, so now we have that one complete. All right, let's do the next one the same way. F of g of 2. I want to find g of 2 first. I'm going to get that off the table. I go to the x value of 2. I go down to the g. says that's -3. So I want to find g of 2 first. So g of 2 is equal to, so let's, you know what, let me show you next intermediate step on that first. So g of 2 is equal to -3. And so then I can find f of -3. So now this is going to go into here. So I'm just showing you that intermediate step. I didn't do that for the one above, but I'm going to go ahead and show you that here. So we're going to find f of g of 2. We found g of 2 first from the table. G of 2 is -3. Now the problem becomes f of -3. We go -3 here. We go down to the f column and we get 11. That would be your answer. F of g of 2 is equal to 11. Okay, next we want to find g of f of 2. So that is the same thing as f of 2 goes inside of the g. So I want to find what f of 2 is first from the table. 2 is here. Go down to the f column, or f row, I should say, and that's going to be a 1. Okay, so that one's right there. F of 2 is equal to 1. Next, I need to find g of 1. Okay, so I go back up to the table. Here's the 1 column. G is, so I get a 0 right there. So I go, x is 1. G of 1 is 0. Okay, so g of 1 equals 0. That's the answer for the whole problem. G of f of 2 equals 0. Now we want to do g of 1. Definition says that. We're going to find g of 1 first, and then put that inside the parentheses here. Go up to the top here. A 1 is there. G of 1 is 0. Okay, so g of 1 is 0. So now the problem becomes g of 0 now. Go to 0. Then g of x, you get a 1. Okay, so g of 0 equals 1. It is the answer to the whole problem. G of 1 equals 1. Then the last one, and then we'll take a look at one of the homework problems. F of 3, the same thing as this right here, f of 3. We first want to find f of 3. Go back to the table again. We go to 3, go down to f, and we get -1. F of 3 equals -1. So now we come back to here, put -1 in there for f. -1 right here. We go down the f column, it's f row there, it's 7. So we get 7 for that. F of 3 is equal to 7. Okay, so this homework problem I'm going to do for you now is, this is coming off of the MyOpenMath. So I'm doing a MyOpenMath problem for you. This problem says f of x is equal to 1 over x minus 4, and g of x is equal to 4 over x plus 3. So part A is asking you to find f of g of x. And then also it's asking you to find domain of f of g of x. Okay, so it's asking to find So this is, again, one of the homework questions. So this here is similar to one that we just did earlier, but I want to go through it again just to make sure we understand how it works. Now, in order to find f of g of x, really what they want us to do is find f of g of x. This means that we want to replace the g of x with 4 over x plus 3, and we're going to put this into the f function. So instead of the x here, I'm going to replace it with 4 over x plus 3. So I have right here, this is what the original f of x looks like. I've got something here minus 4. So I just took out the x in the original f function. I'm going to replace it with 4 over x plus 3. Now, in that first step, you're going to stop for a moment, and this is what's going to allow us to find the define this. So first of all, here, this down here, this here tells us that x is not equal to 3. I'm sorry, negative 3. The reason why is because negative 3 would cause this in the first step to be 0. So I already know that when I do my domain a little bit later, I already know that one number I have to exclude from my domain is negative 3. And that's because putting in negative 3 would cause this in the first step. That would cause division by 0. So always, that's what you do in the very first step. Look at, is there anything that makes the bottom equal to 0? We see that negative 3 would make this fraction 0. So that's one answer that's not going to be, so that's going to be part of my answer. I know that x is not equal to negative 3. But then I have to simplify this further to get the last result, and I'm going to find domain again on that one. All right, so I'm going to do, I need to get common denominators. So I have 4 over x plus 3. This 4 over 1, I'm going to multiply this by x plus 3 over x plus 3. Common denominators. That's going to, if you put this together, now we can combine this together as a single fraction. Just like that. I can simplify the top there, 4 minus 4x minus 12 over x plus 3. And then I can get some like terms. And so that's going to equal 1 over, so I have negative 4x minus 12 here. So the 4 and minus 12, I can combine that together to get negative 4x. That's going to be minus 8 all over x plus 3. And then I'm going to flip and multiply this. So 1, if I just 1 divided by that, I'm just going to flip this over, and that's going to become no more double fractions like that. So I get x plus 3 over negative 4x minus 8. So that's actually what my f of g of x is. I'll put that in here. X plus 3 over negative 4x minus 8. So now I got the domain right there. And then now I need to find, or I have the f of g of x there. So now the next thing I want to do is find domain. Now for this here, I'm going to take the bottom of that, negative 4x minus 8 cannot be equal to 0. And if I solve for this, not equal to 8, I get x is not equal to negative 2. So now I have two numbers that don't belong, that cause division by 0. X is not equal to negative 3, and x is not equal to negative 2. So I put that back into here. I want to write this in interval notation. I have negative infinity to negative 3. Then between negative 3 and negative 2, oops, I don't need a comma there, and -2 to infinity. The way I'm actually visualizing this, if you want to see how I'm getting that notation, basically you would have these numbers in a number line would not be included. -3 and -2 here are not included. And so you're including all the numbers before -3 in between these two numbers and then after -2, and that's how I got all that. And so that would be your two answers for part A there. Now, what it's also going to ask you on this question, it's going to ask you to find the domain of g of f as well. And so I'm going to go ahead and do that for one more problem for practice. Again, we might go a tiny bit over time, but I want to go ahead and take the time, make sure everybody understands how to do this one. So I want to do, so part B here, part B asks you to find g of f of x and domain of g of f of x. Okay, so that's the other thing that this question is going to ask you to do. So this is, won't worry about that. That's the other problem. So now we're going to do part B. First thing we'll do is, here's our the same two original functions again. The g of f is, if I want to find g of f of x is equal to g with an f of x put inside, just like this. And so that means that I have to take out the f of x and replace it with the given formula. So I want to do g of 1 over x to the 4th. That's what that means. Now, if I do that down here, g of 1 over x minus 4, that means that my original function for the g was 4 over a blank plus 3. The blank's going to get filled in with 1 over x minus 4, just like that. Right away, in our very first step, when we plug this in here, we have to look at this on the bottom. We know that x is not equal to 4 because that is going to cause division by 0 in the very, very first step. So when I do my domain, part of my answer there is I know that 4 is not going to be included. Okay, so I know that's part of it. But I have to continue with this in order to find the final simplified answer for g of f of x, and that's the one I'll find domain with again as well. But I already know one number not my domain is going to be 4. Now let's go further here, and we'll get some common denominators. It's plus 3 over 1, and I have x plus 4 over x plus 4. I can write like that. Getting some common denominators. I'm going to get 1 plus 3 times x plus 4 all over the common denominator. So I can add those together now because they do have a common denominator. And then I have, so this is going to be 1 plus 3x plus 12. All that's going to be over x plus 4. Continuing with that further, I can do simplification on this line here. That's going to be 3x plus 13. It's going to be all over x plus 4, just like that. Slow down for a second so you have a chance to catch up there. And you know what? I just realized something here. These should have been minus signs, not plus signs here. Common denominator is x minus 4, not x plus 4. So apologize for that. These should be minus. It means that this down below should be a minus, and this in here is a minus. So there's a minus. So there's a minus here, minus there. This is a minus, and that's a minus as well. So then we get negative 11 here instead. And so let me fix. Apologize for that. I put the wrong thing in there. So make sure I'm showing you the right steps here. This is minus 4. If you flip it, you get 4 over 1 times x minus 4 over 3x minus 13. And you can either multiply it, you can just multiply across the top to get 4 is times both of these things. So 4x minus 16 over 3x minus 13. Okay, so then that right there would be the your answer. I'm sorry, not 13, 11 is what I said here. This is 11 here. 1 minus 12 is 11. So this is 11 here, and this is 11. This is 11. Okay, so 4x minus 16 over 3x minus 11. Okay, so that's the g of f of x. The domain we want to do with interval notation. So 4 is not included. And then also what's going to happen is if you take 3x minus 11 is not equal to 0 and you solve for that, you're going to get x is not equal to 11 thirds. So I know that 4 and 11 thirds don't work. 11 thirds is smaller than 4, because I know 12 thirds would be, if it was 12 thirds, it would be 4. So it's 11 thirds, so I know it's slightly less than 4. Okay, so when I write this, it's going to go net of infinity to 11 thirds to 4, and then from 4 to infinity. All right, so we got that one complete. So that's one of the problems that's in the homework. That's probably the hardest one because it's got 2 fractions that are in there, and I usually get a lot of questions on those. So I just want to make sure that we understand how this one works here, and that's what I wanted to end with. So with that, we are now definitely out of time. We finished all of 5.1, so you should be able to do all that now for there. When we come back on Monday, we have 2 sections we'll do, and both of them are fairly short sections, so we should be able to finish both of those by Monday. Okay, so if anybody has any questions, you can go ahead and ask now. Otherwise, I'll see all you guys on Monday. If you have any questions over the weekend, please feel free to send those to me. I do answer email questions from homework definitely over the weekend. So anybody have any questions now before we go? We'll be doing a test review together. Yes, test review is going to be on Tuesday. Okay, so Tuesday we're going to go over the sample test that's on my website. And I will be sending the class testing instructions today, so you'll be able to know the details on that. And I'll go over those again this week. All right, so if there's nothing else, I will go ahead and end the meeting. Enjoy your weekend. I'll see you guys back on Monday.